So yeah, as was introduced, I'm here from the Manufacturing Technology Centre. I'm not sure how much you know about us, actually. Some people know us pretty well, some people less so, and this is an interesting set of audience, I think, for us. I don't think I normally speak at these kind of events. The topic of my talk is looking at two topics that MTC is really strong on, digital manufacturing and additive manufacturing. We'll look at other things as well, but these are the focus of today, and I think this is most appropriate for this audience, given it's all about digital printing. Additive manufacturing sometimes is described as 3D printing. There's some overlaps in some of the technologies, so hopefully you'll find some aspects of this interesting. The bottom right of the screen there, you'll see the catapult is written there. You may be aware of the catapult network. There's a lot of different types of catapults. They're all designed to help push emerging technologies through to industry, help scale them up, help companies de-risk the adoption of these technologies. And I come from the High Value Manufacturing Catapult, which is a network of 7 centres dotted around the UK. I'm based in Coventry, and you can see all the other centres around the UK, and together we work to try and help companies understand and adopt emerging manufacturing technologies. There's also quite a lot of development needs that still need to happen to take technologies from universities and inventions that companies might have come up with, scale them up, prove them out, enable companies to try them in a lower risk environment than just in their own facility. Typically, we work on technology readiness level 3 to 6, if you're familiar with that scale. Universities focus 1 to 3 typically. Industry typically don't pick things up maybe until 7 upwards. So we're really here to bolster this kind of mid-TRL section of technology development. So I'm going to talk about 2 things, digital manufacturing, additive manufacturing. I'm going to start with additive. And the MTC is the home to the National Centre for Additive Manufacturing. So we're the lead centre in this network for this technology. And it's actually quite a diverse set of technologies. So we don't have everything at MTC by any means. There's a lot of capability spread out across all of these centres. And depending on what technology is appropriate for your application, it will depend upon which centre picks up the work. So the National Centre for Additive Manufacturing is an independent body really designed to support supply chains adopt and mature additive manufacturing. There's 3 key things we normally help companies with. We help them shape their AM strategy, look at understanding whether additive is right for them or not. It's not the right answer in a lot of cases, but it can be. We help them develop their AM products and processes, whether that's equipment or software, or whether it's an end-use application. And then we help companies implement additive manufacturing into production, actually scaling it up for their needs. And that could be themselves having a manufacturing facility or using the supply chain. We have a lot of facilities across that network, and it covers the whole process chain. So it's not just the print bit, if you like, not just the machine that makes the part. It's the whole process chain from design capability through to post-processing and inspection capability, and that all needs to work correctly for you to have a decent manufacturing process. We've got a lot of activity across metal, polymer and ceramics. But a key thing of all of these catapult centres is that we're process and vendor agnostic. We're not trying to sell you a particular technology. We're trying to identify what is right for your application and advise you on how best to get started and then support you in that journey. So this is a bit of a timeline of history of additive manufacturing at the MTC. We've been working on it for more than 10 years now, and there's a website link up there. You can find out a lot more about us outside. This is a photograph of our facility here. It's quite a nice facility in Coventry, so come and visit if you haven't already. We've done a lot of projects on additive over the years. Aerospace sector was a key early adopter of additive manufacturing. Really, additive suits best high-value design needs. So where there's some reason to why you need this fairly expensive approach. So we've done a lot of work with Rolls-Royce, who's one of our lead members, but there has been overspill into other sectors. So as aerospace have taken the lead with a lot of this, other sectors have followed. So the National Centre itself was opened in 2014, which is funded by the Aerospace Technology Institute. And then since then, we've done various additional activities. A lot of work for the space sector, and we're the European Space Agency's Additive Benchmarking Centre, and we're also doing a lot on standardisation. So ASTM launched a centre that we're a founding member of. Also do a lot on training. So if you're not familiar with additive manufacturing, we can help you get your bearings. It's quite a confusing area. We've got a lot of courses we run, and also we've got a lot of knowledge that we can share. So the whole point of our centres is that we're open access, we can share best practice. You don't have to fight through kind of commercial priorities. So the key areas that we work on, there's two key things really. We're trying to industrialise existing additive manufacturing. So companies now want to try and get some benefit from it. There's technologies that are available. How do we use them for actual applications? So this is around looking at how we qualify manufacturing processes, how you design a component, how you make sure that you understand the variability and the inherent costs and the challenges that current generation additive manufacturing has. But then we're also looking to mature the next generation systems. Additive manufacturing is a very rapidly developing area. Every year or so, your machines are becoming kind of out of date. And there's a lot of new developments going on to improve the quality, improve the speed, improve the economics of it. These are the three pillars that we look at in this area. Getting better quality, increasing the rate and the size capability, so being able to go bigger with your parts, and then looking at emerging materials. The material properties are obviously critical to your application, and additive hasn't had a decent breadth of materials, and that's still getting better. But there's a lot of activity in that area. And across all of this, we're really trying to support environmental sustainability approaches, obviously a really important priority at the moment. And this is something that's driving everything that we do. I thought, given the audience here, I don't know a lot of your companies very well, but I am familiar with companies that are in the 3D printing or additive manufacturing space, and it's interesting to see quite a lot of what I would think of as traditionally 2D printing companies exploring the 3D printing market. And I didn't know if this was interesting or not, but I've got a few slides here of some companies and what they're up to at the moment with 3D printing. Additive manufacturing is a very diverse field. There's lots of different types of technologies, and there's lots of different suppliers that are trying to make money in this industry. And a lot of the 2D printing companies, I guess, are a little bit concerned at maybe the direction of travel with some of the physical printing direction, at least from a layman's point of view for your industry. There's, I guess, more digital displays, less physical printing. There's fewer people in offices and things, and fewer people printing things out. And the inkjet printing technology is a really interesting one for additive because it is inherently more scalable than some of the other technologies that are around. So some of these printing companies have got really good technology, and that is potentially applicable to additive. So first of all, Epson, they've only fairly recently entered the 3D printing market with a kind of a metal extrusion type system. Ricoh have been around for a while. 2015, they kind of made a start in polymer, and then have more recently been doing stuff in metal, binder jetting. I don't know if you're familiar with the technologies, but this approach really uses a lot of jetting inkhead kind of technology. And the more scalable processes tend to use this. Canon's recently come in with a ceramic 3D printing technology. Xerox have been doing quite a bit in this space. They bought a company in 2019, Vader Systems, which is a metal jetting type of process. But interestingly, they've kind of scaled that back now. What you see is a lot of companies trying to guess which is the right technology for the market, and they're buying companies, they're buying small startups and testing a bit, but then wrapping them up if they don't work. Xerox also invest in this startup, which is a metal high rate process, which has a lot of potential. A few others here. Xaar's just disposed of its part of its business to Stratasys, which is a more established 3D printing company. But again, Xaar's done a lot of work on the jetting side of the technology, so they've done quite a lot. And I'm not familiar with these two companies myself, actually, but just for information, you might be aware that there's some activities there. And then finally, HP, who have been working on this for quite a while now, since 2016. massive amount of investment into polymer 3D printing to start with. And now they've been working on metal jetting, which is a metal binder jetting process here. And it's interesting, so this is just from a recent article. You know, there is a lot of hype around additive and 3D printing, and it hasn't met HP's early hopes of the technology, but they still believe in it long term. And you know, they have this quote here, it's, you know, it's really easy to underestimate the longer term and overestimate the short term. And it's because everyone's still kind of grappling with what are the best use cases for this technology. It's not suitable for everything by any means. And you know, there is a lot of potential for it, but sometimes it's hard to judge when's the right time. And this final slide on the additive side of things, before I move on to digital, again, just so you've got a basic awareness, there's a lot of development going on, and this is just metals, and you can see a range of technologies. So this one is supposedly up at widespread industrial use. You might question that to some extent, but then you've got all of these other technologies that are coming about. And what we do as a Catapult is try and support development of these, try and get access to these technologies within the UK where they don't exist, because they're often international companies, and we can acquire equipment, put them on our site, have our staff suitably trained so that you can then come and work with us and explore them. And a lot of this equipment is not in the UK anywhere else, and there's no supply chain for it. So if you want to explore additive manufacturing, come and speak to us. We've got a lot of knowledge. At the MTC, we've got about 100 people working on additive manufacturing across the network completely. There's a lot more than that. So yeah, so that's a bit on additive. Hopefully that was interesting. The second half of the talk is now on digital manufacturing. This slide summarises our key capability areas. We've got 3 main research groups: component manufacturing technology, of which additive manufacturing is one of those, digital engineering and advanced production systems. And we've also got our transformation team, which is more around consultancy, going into industry and helping them adopt the technology kind of through you know, exploratory line walks of their facilities, basically translating what we've done here into industry. And then we've got a lot on skills. We're trying to match people development with technology development so that when you adopt the technology within your company, you've also got a workforce that is able to operate it. So digital engineering is this one in the middle. This is the one I'm in. And we've got 3 departments: modelling and simulation, metrology and non-destructive testing, and informatics. And what we're trying to do is some of the things that are shown on this graphic here. So we're trying to get smarter factories, we're trying to get smarter designs, smarter supply chains, and to help companies adopt what is often called this Industry 4.0 term. You know, it's all around digitalization, automation, and we've got facilities and expertise where you can come and learn about these technologies, similar to the additive, but you know, these are a different set of technologies. So we're looking at doing different things like gaining insights into usage patterns, looking at predicting your maintenance, looking at improving process and quality control, optimizing your supply chain, trying to get all this data to come in real time so you can make decisions at the right time. Trying to use digital techniques to help improve safety. So how can you support your workforce when they're in a facility with some digital tracking things, and then also eliminating waste. So we've got at the MTC a number of digital platforms and test beds. So these are in one way demonstrators, so you can come and see Industry 4 technologies. You know, sometimes digital things can be a bit ethereal and a bit digital, but there is physical aspects to it. So you can come to our site and see things like a factory in a box. So this is a shipping container with a lot of equipment in it that is intended to be deployable and then remotely controlled. You can see a digitally reconfigurable additive manufacturing facility that tracks data from the additive manufacturing machines. And we've got a variety of others. We've got a 5G private network, and we've got ability to do this kind of like augmented reality prove out of facilities as you're designing them. And one of our most recent and biggest activities is a thing called DMA here, which is a Digital Manufacturing Accelerator. So it's a big program that we're leading out of the Liverpool region, and it's got 2 key assets that are useful. One is a digital factory environment, and one's a rapidly reconfigurable factory environment. So we've got a virtual one on the left and a physical one on the right. The idea of the DFE, Digital Factory Environment, is that this is like a sandpit. It's like a test bed for you to explore digital techniques, so different systems, different softwares, different architectures, in a way that doesn't mess with your own facility. And we can kind of spin this up so it replicates what you do, and you can access software and interface with it to test things out. And then the rapid reconfigurable factory environment is some demonstrators that show modular manufacturing and physical interactions. It's a little bit like these things, but different ones, and particularly targeted at the pharmaceutical industry. And this slide summarises kind of the key aspects of this, the things that it's going to have. So you might have heard the term digital twin. That's the idea that you've got this virtual representation of your physical, and there's some interlinks between it. It's like a cyber-physical system. So things that you'll have access to through this is data and computing power on demand through the high-performance computing capability. We've got different modules that can be tested. We've got a digital infrastructure that you can configure to suit your needs, and then you can kind of mess around with it to try different things out, different scenarios, without it messing up your own production. We've got a portal where you can access the data and the systems in there. There's a library of systems and simulations that you could deploy. And then on the right, I think I've covered that already, really. It's touching upon the same thing. And then at the bottom here, we've got factory space where you can have equipment that's relevant to your industry. So the idea is really of the catapult centres is that we've got quite flexible workspace that either we can put your equipment in if you buy it and want to put it in a confidential cell, or you can use the equipment we've already got and configure it to suit you. But the idea is that you can speak to us and we'll try and help you where you're at and meet your needs. So a typical customer journey that you'd come on with us follows these 4 phases, really. First one is to discover what your challenges are. You sit down and have a conversation with us like any company, and we try and understand where the needs are for your industry, what are the big challenges that you've got, and then you can understand some of the basic principles of the technologies and what they could mean for you. Second thing is around planning. So this is where we get into a bit more detail and maybe plan a project, maybe look at developing a roadmap for your business. Third one is to then actually do some physical design and build activities. And then fourth thing is looking at how you'd operate and maintain that once it's within your facility. How do you make sure that you can keep this facility working and be supported appropriately. So we've got lots of experts that can support on this, and I encourage you to speak to us if you're interested. And then last couple of slides before I finish, we're almost out of time. There's some demonstrators here. So some examples, there's case studies on our website with actual industrial companies shown, but you can use these digital manufacturing techniques for things like virtual commissioning. So you can look at 3D representations of your product, of your manufacturing line, of your facility before you make it. You're proving out the design more concretely, and you can use augmented reality, virtual reality. You could walk through it and see it immersively. You can do digital evaluations of designs or looking at work instructions and things. So say you've got an assembly process and it's maybe quite complicated. Someone who's assembling that can have instructions coming up on their augmented reality system, and you can also use it for traceability, so you can make sure people have done it and it's verifiable. You can use these techniques for maintenance, so improving your predictive maintenance or adaptive maintenance schedules, and these are some examples of dashboards that we've created for companies. And also looking at then your supply chain, how can you manage what's going on there? So some dashboards. And then the last slide here, sustainability and waste management, it can be useful for security. This is quite an interesting one. I mentioned health and safety earlier. So this is people walking around factories being tracked, obviously with privacy, so you can't see their faces, but it's alerting people if they say walk out of the yellow lines, the safe yellow lines, or if they haven't got the right PPE on for certain activities, it will alert them, and it's about helping keep everyone safe. And this thing here is around tracking people that's in that factory in a box, factory in a shipping container, making sure they don't get locked in, simple things like that. And then data management, you can do a lot on that front. Anyway, I'm out of time. That's exactly 20 minutes. And so happy to take any questions in the break. I don't think we've got time now, but if you'd like to contact me, I can introduce you to some of my colleagues and then maybe we can see if we can help. Okay, thank you very much.